The marsh is silent at 4 in the morning. Not the silence of sleep, the silence of waiting. Then, without warning, a single reed warbler lifts its voice into the darkness. Not at dawn, not even close to dawn. 3 hours too early, in a black sky still heavy with stars, this small brown bird begins to sing as if the sun has already broken the horizon. Within minutes, another joins, then another. By the time the first grey light actually touches the water, an entire wetland is singing a chorus that should not exist yet. A performance staged for an audience of nothing, in a theatre still wrapped in night. For decades, ornithologists treated this as a curiosity, a footnote, an oddity of urban-adjacent bird populations confused by streetlights. But something has changed. The phenomenon is no longer confined to cities. It is spreading into wilderness, into protected reserves hundreds of kilometers from the nearest artificial light. And the birds singing earliest, scientists have discovered, are not the ones near light pollution at all. They are the ones near something else entirely. Something buried, something most of us will never see, and yet something that may be reshaping the rhythm of life itself. What do you do when an animal's internal clock, a clock shaped by hundreds of thousands of years of evolution, simply stops trusting the sun? To understand why this matters, you have to understand what a bird's song actually costs. Singing is not free. Every note a male reed warbler produces in the pre-dawn hours burns calories he cannot easily replace in darkness, when insects are scarce and the cold drains his small body faster than daylight ever could. Singing also exposes him. Sound travels through silence the way nothing travels through noise. A single bird singing at 4 a.m. is a beacon to any predator with ears tuned to that frequency. For a creature that weighs less than a slice of bread, this is an enormous gamble, so why take it? Throughout history, dawn song has been one of nature's most precise instruments. It is timed not by guesswork, but by an extraordinarily sensitive internal clock, a circadian rhythm fine-tuned to light intensity, air temperature, even barometric pressure. Singing at the correct moment of first light maximizes the chance a female will hear the song while she is most receptive, while territory disputes can still be settled before energy is needed for the day's foraging, while the still air of early morning carries sound farther than the turbulent air of midday. Dawn song is not decoration, it is survival mathematics, refined across geological time, which means when that mathematics breaks down, when birds begin singing in pitch darkness, hours before the equations of evolution say they should, something underneath the surface of the world has shifted enough to rewrite the calculation. The first researchers to take this seriously were not ornithologists at all. They were soil ecologists working in wetland restoration sites across Central Europe, tracking something far less glamorous than birdsong, methane seepage from disturbed peatlands. Peat is one of Earth's quietest miracles, formed over thousands of years from partially decomposed plant matter in waterlogged soil. Peatlands cover only 3% of the planet's land surface, yet they store more carbon than all the world's forests combined. They are, in essence, vast underground vaults of compressed time, the slow accumulated breath of 10,000 summers locked beneath the surface, waiting. But peat is fragile. Drain it, disturb it, warm it even slightly, and that vault begins to open. Methane and carbon dioxide seep upward through the soil in slow, invisible plumes, imperceptible to a human walking across the same ground, but not imperceptible to everything else. Insects are exquisitely sensitive to subtle shifts in soil gas chemistry. Studies tracking invertebrate emergence near degrading peatlands have found that certain insect populations, midges in particular, a primary food source for many wetland songbirds, begin emerging earlier in the night as underlying soil temperatures rise even fractionally above historical baselines. The insects are not responding to light, they are responding to heat rising from below, heat the birds above them cannot see, cannot smell, cannot consciously register at all. And the birds, attuned over evolutionary time to track the presence of their prey with uncanny precision, are following them into the dark. This is the theory that began to take shape, not light pollution confusing birds in cities, but disturbed peat releasing trapped heat and gas into degrading wetlands worldwide, altering insect emergence patterns by mere hours and pulling bird behavior along with it like a thread tugged loose from a much larger tapestry. it would have remained an obscure regional finding if not for what happened next. In 2019, a team led by Dr. Edmund Hale's frequent collaborators at a remote field station in Siberia's western lowlands, one of the largest peatland systems on Earth, began documenting something that defied the original hypothesis entirely. The early singing was not isolated to wetland edges. It was radiating outward, kilometer by kilometer, year by year, like ripples expanding from a stone dropped into still water. And when researchers cross-referenced the expansion pattern with satellite thermal imaging, they found something that silenced the room when it was first presented at a conference in Helsinki. The radius of early singing bird populations matched almost precisely the radius of permafrost thaw beneath the peat. Permafrost, and ground that has remained frozen for thousands, sometimes tens of thousands of years, is not simply ice. It is a seal, a planetary lid holding ancient organic matter in cryogenic suspension, matter that has not decomposed, has not released its carbon, has not rejoined the active cycle of life and decay, because it has been locked in frozen stillness since before the pyramids, since before agriculture, since before humans painted the first images on cave walls. When that seal breaks, what was frozen begins, for the first time in millennia, to breathe again. Microbial communities trapped in permafrost reactivate. They begin consuming ancient organic matter, releasing methane and carbon dioxide as byproducts, generating subtle but measurable heat in the process. This heat rises through the soil layer by layer, reaching the surface not as a dramatic eruption, but as a barely perceptible warming, half a degree here, a degree there, invisible to any human walking the same ground, but profoundly audible to the small, fast metabolizing creatures whose entire existence depends on reading the Earth's temperature with infinitely greater sensitivity than we possess. The insects feel it first, the birds follow. And somewhere in that quiet chain of cause and effect, a wetland that looks to any casual observer exactly as it has for centuries. The same reeds, the same mist, the same dawn light breaking gold across still water, is in fact whispering a warning that only its smallest inhabitants can hear. Is it strange, do you think, that we built our entire understanding of planetary change around what is visible to us? Smoke, flooding, fire, the dramatic and the photogenic. Meanwhile, the most consequential transformations may be the silent ones. Heat rising through frozen soil, insects shifting their internal calendars by minutes, then hours, then birds singing into darkness because the rules they were given by 10,000 generations of ancestors no longer match the world beneath their feet. We are, perhaps, the only species on Earth capable of measuring catastrophe and still failing to feel it. The implications of the bird research extend far beyond a curious shift in dawn-chorus timing. Early singing, researchers found, comes at a measurable cost to reproductive success. Males singing in full darkness expend more energy and face higher predation risk, yet do not always succeed in attracting mates who are themselves still following older circadian patterns. The mismatch creates what ecologists now call a phenological trap, a situation where an animal's instinctive behavior, once perfectly adapted, becomes a liability because the environmental cues it relies upon have shifted faster than evolution can correct for. Phenological traps have been documented before. Caterpillars hatching before the leaves they depend on have unfurled. Migratory birds arriving at breeding grounds before the insects they need to feed their chicks have emerged. But the peatland singing phenomenon represents something different, a trap triggered not by surface-level climate shifts alone, but by something happening beneath the ground, in systems most conservation efforts have never been designed to monitor. For over a century, wetland conservation focused almost entirely on water levels, vegetation cover, and surface biodiversity counts. Peat itself, the dark, spongy foundation beneath the visible ecosystem, was treated as inert scaffolding. Background, not a living, breathing component of the system, but simply the ground the system stood upon. This research suggests we had it backward. The peat is not the stage. The peat is, in a very real sense, the conductor, setting tempo and timing for everything that lives above it, in ways too subtle for centuries of human observation to detect, but not too subtle for a bird whose entire survival depends on perceiving the smallest fluctuations in its environment. There is something almost humbling in that. We spent generations studying birds by watching their feathers, their flight patterns, their nests, and it turns out one of the most important things they were telling us all along was encoded in something we could not see at all, the precise minute they chose to open their throats in darkness. By 2022, the early singing phenomenon had been documented across boreal peatlands in Scandinavia, Canada, and Siberia, correlating consistently with measurable subsurface warming. Conservation biologists began proposing something radical, using dawn chorus timing itself as an early warning system for permafrost degradation, a kind of living seismograph, far more sensitive and far cheaper to deploy than the satellite and sensor networks currently used to monitor thaw. Picture it. Not satellites, not drilling rigs, not networks of buried thermometers costing millions to install and maintain across some of the most remote terrain on Earth. Just birds. Small, ordinary, anonymous wetland birds, already present in these ecosystems by the millions, already singing every single morning, already encoding within the timing of their own voices a precise record of what is happening in the frozen ground beneath them. Nature, it seems, has been running its own monitoring network since long before we built ours. We simply never learned to read the data. There is a particular kind of awe that comes from realizing how much intelligence exists in systems we assumed were simple. We tend to imagine complexity as something built, wires, code, satellites in orbit, sensors buried in concrete. But complexity has also been growing, quietly, in feathers and song for tens of millions of years. Refined not by engineers in laboratories, but by the unforgiving arithmetic of survival itself, generation after generation. Failure after failure, until what remained was something close to perfect. A bird does not know it is measuring methane. It does not understand permafrost or microbial respiration, or the long chemistry of ancient carbon reawakening after 10,000 years of frozen sleep. It only knows that the air feels different tonight, that something somewhere beneath its feet has shifted in a way its body cannot ignore, and so it sings, not as a warning meant for us, but as an honest, instinctive response to a world that is, in this very moment, quietly rewriting its own rules. We are only the accidental recipients of that information. Eavesdroppers on a conversation between insects and soil and frozen time, a conversation that has been happening for millennia in frequencies and timescales we are only now learning to perceive. Perhaps this is the deeper lesson hidden inside a marsh at 4 in the morning. Disaster does not always arrive as spectacle. It does not always announce itself with flame or flood. Sometimes it arrives as a single bird singing 3 hours before dawn, a small deviation from a rhythm so old it predates language, predates fire, predates almost everything we consider civilization. A deviation easy to miss, easy to dismiss as strange, easy to walk past without a second thought. But if you stand still long enough in the cold and the dark, and let that unexpected song settle into you, you begin to understand that you are not simply hearing a bird. You are hearing the earth itself, translated into a frequency one small creature has spent its entire evolutionary history learning to interpret faithfully, even when faithfulness costs it everything. What would it mean, do you think, to listen to the world the way that bird does, not waiting for catastrophe to announce itself in headlines, but trusting the subtlest shift in rhythm, in light, in warmth, enough to change our voice before the danger becomes undeniable? The marsh does not know it is being studied, the peat does not know it is thawing into significance, and the bird singing into darkness does not know it has become a messenger, carrying a warning none of us asked for, in a language none of us were taught. And yet here we are, listening anyway, learning, slowly, painfully, to hear what was always being said, if only we had thought long ago to ask the birds.